In this lecture, we're going to explore the unit circle and how the trigonometric functions work with that unit circle, how they fit in. First of all, we know that a unit circle has to have a radius of 1, and we center it around the origin. In an xy plane, it's a set of points xy that satisfy the equation. Besides the points that are on the axes here, which are all at +1 and -1, right in between those two numbers, we know that all the other values along the circle there would have to be less than 1. For example, if I pick another point here, we see that its x value and its y value are going to fall within the unit circle there. So they're going to be values that are less than 1 or greater than -1. Here we go, just down here. So more than -1 but less than 1. They're all going to fit any point that's along the circle between -1 and +1. If we have a radius of 1, that simplifies a lot of my calculations here. For example, when we talk about the circumference of the circle, the distance around the circle, we know that the formula for the circumference of a circle is 2 pi r. So if r is 1, then we know that the circumference is 2 pi. In other words, one revolution around this circle takes us 2 pi units. Symmetry also, a circle gives us a lot of symmetry, almost all the symmetry you'll ever need. So for example, when we talk about, let's just take this point here, AB, if I fold it across the y-axis, I can see that there's going to be another point that's also on the unit circle. Notice that they have the same height, right? That's why their B is there. And they're the same distance to the x-axis from the center. So if this is at A, then we would say this is -A. We can also fold it across the x-axis, and we get the same A and -A values. And the y value is the same distance as it is above, -B. So in a negative direction, but the same distance. We also have symmetry around the line y equal to x here with this point, which means that those are the inverse points, right? So if we switched A and B, we would have B and A. So this falls the same distance as I am above up there at B. So this distance to here and this distance to here along the x-axis, same. And then same thing with the A. The distance from here to my A is going to be the same distance here as well. So at any rate, lots of symmetry going along here in a circle. Obviously, it's a circle, so there's in every way you turn there's some symmetry. Okay, so here we have a problem where we're first asked, is this point on the unit circle? And if it is, use symmetry to find the 3 other points that are also on the circle that have a relationship with this. So how do we prove that it's actually on the unit circle? The x squared plus y squared equal to 1 is the equation for the unit circle, where the radius is 1. 1 squared is 1, so r is 1. And if I plug in the x and the y value, if they are squared and add up to 1, then we have symmetry. Then this point is on the unit circle, and hence we'll have symmetry. So I'll want to take the x value, square it, the y value squared equal to 1. So this gives me 4/9 plus 5/9. Square root of 5 squared is just 5, and the square root of 3, or just 3 is squared is 9. And when we add these together, we get 9/9, which is 1 So it is this point, 2/3 and square root of 5, negative square root of 5 over 3. I forgot to put the negative in there. It is on the unit circle. And this still works. The negative square root of 5 over 3 is also becomes positive 5/9. So now let's take a look at finding the other points. So the point, 2/3 and square root of 3. So I'm going to go out to where x is about 2/3 of the way. Go up. And we'll just go ahead and mark this point. Oops. Sorry, I want to go down. It's negative. I got the wrong point there. Erase that. So this point is at 2/3 and negative square root of 5 over 3 as an ordered pair. Now we want to find the other one. So going up, so folding it across the x-axis here. This has the same x. We're still going 2/3, so the symmetric point would just be the two positives of these. Folding it across the y-axis is going to put me here at the same height that I have here, and it should put me at the same distance from the center as well, since I'm folding it across the center. In this case, I'm going back 2/3, but I'm still going up square root of 5 over 3. Looking at it, going down, folding across the y-axis there, or the x-axis, we're still at negative 2/3, but now we're at negative square root of 5 over 3. And these are all the symmetric points for my first one. All we did was really change the signs. If you'll notice here, they're both positive. Here we have a negative with a positive. Here we have two negatives, and here we have a positive and a negative. So they're switching all of those spots there. Here we're asked to find all the points on the unit circle whose y-coordinate would be 3/5. So first we need to find the x-coordinate of all points, if any, of the form x 3/5 that will satisfy the equation x squared plus y squared equals 1. X squared plus y squared plus equals 1 is the equation of our unit circle. So if we let y equal 3/5, let's go ahead and just write that out. And go ahead and carry that out. That gives me 9/25, which I can then subtract from 1. Subtract from both sides. We see x squared is equal to 1 minus 9/25, which would be 16/25, which we can then take the square root of both sides. We see x is equal to positive and negative 4/5. So the points on the unit circle, just going with what I've found here, would be negative 4/5, 3/5, and positive 4/5, 3/5. Could that be the only point that would have 3/5 as a y-coordinate? Well, again, let's look at the unit circle, which is, I know, a horrible representation. 3/5 is a specific y value, right? It's a y value. And I'm trying to get rid of that annoying line that always seems to pop up. I don't know why that is. 3/5. It's probably because my hand is resting on the screen. It's a specific value, and it's positive. They very specifically just said positive 3/5. It's going to go to, using symmetry, an x value that, if we look at it as a and negative a, would be just the same number but different signs. And so this is actually the only two that could possibly have 3/5 as a height. So these are the 2 points on the unit circle. The two functions sine and cosine are actually very specifically related to the unit circle. They're all related to the unit circle, but sine and cosine are especially so. In fact, let's take this point here, and I'm going to just draw a line to it. We know that on the unit circle, as opposed to other circles, unit means 1. And so 1 is the hypotenuse if I draw this out as a triangle, which we've looked at before. All right, and there's a specific A, and let's just say B, where A, if you'll notice, there it is again, is a point along the x-axis there. This value here, in fact, if we say it's A, and the height here could be at B, and it is, right? This is the distance. If we're looking at this as a x-coordinate, the x-coordinate is the distance to here, and the y-coordinate is the b value, the height of the triangle. So this xy we can write as a and b. Now I say that only because I want to demonstrate that with 1, when I talk about this angle here, and I'm just going to put t as the angle, even though usually, we use theta a lot. But if we took the sine of t, sine, remember, is opposite over hypotenuse. Well, the opposite side is b, and we're putting it over the hypotenuse, which is 1, so really just the sine of t is b, which is the y-coordinate of that point. Cosine of t is adjacent over hypotenuse, and that is a over 1, which is a. So the cosine of t is actually the x-coordinate of this point on the unit circle. So just connections to be made here, right? Cosine of t, cosine of the angle that's created here, is the actual x-coordinate of the point that's on the unit circle, and sine of t, sine of the angle that's created there, tells us the y-coordinate value of the point that's on the unit circle at angle t. Also, t as a radian is, the radian is defined as being the arc length, right, of a unit circle. So looking at the larger picture here, we see that we have these relationships. Cosine of an angle t, which could be any real number, and the sine of t, these are both x and y coordinates of the unit circle. The tangent is the ratio of y over x. And then these are just the reciprocals of those 3 things. Again, building on our knowledge of what these things and what the consequences are of them. All right, so evaluating trigonometric functions, find the values of any of the 6 trigonometric functions at each value of t. So here we start off with the value of 0. Let me go down to the bottom here. For each value of t, find the corresponding terminal point p of t, x, y on the unit circle. Then use the definitions of the trigonometric functions. Okay, so let's start off with t equal to 0. If my angle, t, is equal to 0, so that's 0 radians, then this is the point that I'm at. If I haven't traveled any units here on my unit circle, so that distance is 0, then I don't have this here. I'm just sitting right here. Let's look at the x and y coordinates here. So this would be at 0, 1. I'm sorry, I have that backwards. 1 and 0. 1 for x and 0 for y. So let's first start off with sine and cosine. Remember, cosine of an angle, which we're going to put, in this case, is 0. Yikes. Is equal to, well, it's the x-coordinate of my point that's on the unit circle, right? And we know that coordinate is 1. So cosine of 0 is 1. Tangent of 0, I'm sorry, not tangent, sine of 0 is actually the y value of the point on the unit circle. So this is actually 0. The sine of 0 is 0. What about tangent? Well, tangent would be the y over x, right? So in this case, our y value is 0. The x value was 1. So the tangent of 0 is also 0. Let's do these other ones. What about the secant? Remember, secant is the reciprocal of the cosine. And, well, cosine is 1. So the reciprocal of 1 is just 1 over 1, which is still 1. What about the cosecant of 0? Well, the cosecant of 0 is the reciprocal of 0, which would be 1 over 0, which is never allowed. So we say that the secant is undefined, and we also run into the problem with cotangent as well. The cotangent of 0 would also be 1 over 0, which is not allowed, so we'd say it's undefined. Remember that 0 with a line through it is not 0. It's the empty set. It means this cannot be done. All right, what about t equal to pi over 2? We know that pi, if you remember, is all the way around, so sort of 180 degrees. It's equal to 180. If we divide that in half, then it puts up here to 90. So the T2 would be the point up here. This is the distance from 0 all the way up to here on the unit circle. It is 1 pi, but then divided by 2. So this is 0 for x, 1 for y. So we have a very similar breakdown here when we start looking at the sine. The sine of t is equal to, and t in this case is pi over 2. So I'm going to just write that in there instead of writing t. We'll put in pi over 2, which is the same as 90 degrees, but it's equal to the y value there, which is 1. The cosine of pi over 2 is the x value that's there, which is 0. So they've just switched spots. And the tangent of pi over 2 is going to be the x over y, because, it's y over x. Y in this case is 1, x in this case is 0, and so that gives me something that's undefined. So tangent is undefined at 90 degrees or pi over 2. Then we go cosecant. The reciprocal of that would be 1. The secant of pi over 2, I forgot my angle there, pi over 2, is equal to 1 over the reciprocal of 0, which is undefined. And then the cotangent of pi over 2, the reciprocal of tangent, would be 0 over 1, which is allowed and just results in 0. All right, now we're going to do it for pi. Pi is taking us all the way across to the other side here, where this point here is -1, 0. I'm going to start off with sine again. So the sine of pi is the y value, sine is y, and y in this case is at 0. Cosine is the x value, and cosine is at -1. Tangent of pi is y over x, so 0 over -1, which is 0, which means the reciprocal of sine is my cosecant. So cosecant of pi is going to be the reciprocal of 0, which can't be done. For tangent, the secant, I said tangent, I don't know why, but secant of pi is -1. The reciprocal of -1 is still 1 over -1, so still -1. And we can see that the cotangent of pi will be undefined as well. So in this case, the cosecant and the cotangent are both undefined. For 3 pi over 2, now this is taking us all the way over here. So way over here, we're almost doing one complete rotation. But this is at 270 degrees, 3 pi over 2. 3 pi over 2, so 390s. So we went 190, 290s, 390s, 3 pi over 2s. And at this spot, we have 0 for x and -1 for y. So starting off with my sine of 3 pi over 2, we know that the sine is the y value, so this is equal to -1. The cosine of 3 pi over 2 is going to be the x value here, which is 0. And then tangent, in this case, for 3 pi over 2 is y over x, which would be -1 over 0, which is not allowed. And so we say undefined. Secant, or sine, goes with cosecant of 3 pi over 2. -1 will be -1 as well. The cosine, the secant of the same, 3 pi over 2. Since cosine is 0, we know that this is going to be undefined. And tangent, the cotangent of 3 pi over 2 will be allowed. It's 0 over -1, x over y, and that gives me 0. Remember, 0 and the empty set are not the same thing. 0 is an actual number, but undefined is not a number. The last one we have here is -3 pi, which, because we already did 0, so 2 pi would be the same. But if we go back 3 pi, where does that take us? Well, this is 2 pi's, right? Remember, pi is 180. So from here to here is 1 pi. Here to here is 2 pi. And so if I want one more pi in a negative direction, we have to go one more pi around. So that takes us here on the unit circle, which is right here. So -1, 0. And so these are going to be the same results that I had for pi, which went from here to here. The exact same trigonometric functions. The sign for that, which is the y is at 0. For cosine, we're at -1. And for tangent, which is y over x, that would be 0 over -1, which is 0. Meaning that cosecant of -3 pi, this one is undefined. The secant of -3 pi is -1, and the cotangent of -3 pi is undefined as well. Two undefineds are cotangent and cosecant. Here is a table of some common, the patterns that we see here with the symmetry that we had, and just some of the common angles that we use a lot of. 0, 30, 45, 60, 90, 180, 270, 360. These are all pretty common things that pop up a lot. And so we can begin to start that process of memorizing them. And I would recommend you have this as a little reference tool. This would be a great thing to have, for example, on your 305 card. Some connections I want you to make here. We saw like 0 degrees, which was 0 radians. We saw pi over 2. Where is that? Pi over 2 is right here. We saw those different outcomes there. 1, 0, undefined 0, undefined 1. 0, -1, 0, undefined, -1, undefined. The last one we did, in fact, was equivalent to pi, right? It was -3 pi. The two that were undefined were cotangent and secant. The same ones that had the reciprocals were 0. So like for pi, sine was 0 and tangent was 0. So their reciprocals, cotangent and cosecant, are the two that are undefined. Pi, remember, is 180. So if you take 180 divided by 6 ways, you get 30 degrees. Pi being 180 divided up evenly 4 ways is 45. Remember, 2 ways is 90, so if we cut that up twice again, that's 45. And pi divided up 3 ways is 60. Remember, 18 is divisible by 3 and 6. And also 2 and 4. Okay. So anyway, this is just a reference card for you. It gives you what all of these are. And you'll notice some patterns that begin to develop, which will become a little more second nature to you. And we're going to examine those a little bit more as we go. This is another super helpful picture because it gives us and puts it into context of what sine, cosine are. So it's purely focused on the values of sine and cosine, and keeping in mind that we can get all the other ones from that. They're all sort of built off sine and cosine. And you can go in the negative degrees as well. I think the next slide. No, sorry. Yeah. So let's do a couple of these. And we're going to do these using a calculator in this case. So we're going to set our, for the first one, for A, we're going to make sure we're set to degrees. If you were, you may already have it in degrees, but we'll see where we're at. So sine of 71, this is pretty straightforward because sine is straight up on my calculator. So I just type in for A, the sine of 41. Or 71, sorry. Oh, I'm getting 41. But as I was saying it, I was typing. That almost made me type 41. At any rate, sine of 71 is 0.9455. 71 is not any kind of special coordinate. It's not a 30. It's not a 60. It's not a 45. It's not even close to any of those things. And so we're just going to round this to 4 digits when we do it. For B, we want to set our mode, go back into mode, and set it to radians. This will be true for the next 2 problems. And typically, a lot of times with these radians, we see them put in terms of pi, and that's okay. We can type these in that way as long as we're in the radian mode. Now we're taking signs not of degrees, but of any real number that's out there. 5 pi over 7 being one of them. So taking tangent, we have a tangent button. I'm just going to put 4 or 5 times pi. If you're using a TI 83 or 84, the pi button is actually located above the hat key. The hat key looks like this. And that's on the far right. So if we go second hat key, we get 5 pi, and then divided by 7. This is negative 1.8 3, but I'm going to go ahead and round it to 4. Because it was 3 followed by a 9. So that's pretty close to the actual value, but it is approximate. So I'm going to turn these into little approximation symbols there instead of equals. And then keeping it in radians, we can find the secant of 1.3. But notice there's no secant button. But it does have a relationship to cosine. So as long as we're in radians, I'm going to go cosine of 1.3. Get the answer. And then I want to flip that answer around. So on my calculator, you'll notice on the far left side, if you have a TI 83 or 84, there's an x to the minus 1. This is a number raised to the minus 1, which flips it, basically. So if I just hit that button, it automatically will write ANS. That means answer to the negative 1, meaning the reciprocal of that answer. If we hit enter, we get the actual value here, because remember that secant is the reciprocal of cosine. So I took the cosine and I found the reciprocal, 3.738 is what it would round to. That again is also an approximation. So I'm going to put the squiggly lines there for my equals. Sometimes you might, instead of seeing answer to the minus 1, or I'm sorry, x to the minus 1, you might have a button that's 1 over x, where when you hit that, it'll flip it for you. Both of these mean the same thing. In fact, x to the minus 1 is equal to 1 over x. So whether we're dealing with degrees or whether we're dealing with radians, we can use our calculators to do this. When it comes to special values, 30 degrees, 90 degrees, 60 degrees, 45 degrees, we have some very specific numbers we can use here to express our answers in an exact way, which is always preferable to decimals that we have to round. Exact is great because we're not rounding. So when we're plugging them in for solutions into equations, we're getting the left-hand side being exactly equal to the other side rather than just being very close. That's our lecture for 4.2.